Right, so to finish off the lecture, we're going to look at another data set. This is a higher dimensional data set. So this has 10 variables, and these are product ratings. So it's actually a very small data set, but it's higher dimensional. And the idea behind this, again, it's fictional data, but the idea behind this is the customer asks for a detailed rating of each product that it's selling. Detailed rating in 10 categories, so more than you'd normally ask for, I think. And that then gives us the 25 products, and each product has 10 ratings, and their average, we get an average rating for each of those categories. And what we can do, first of all, what we could do is use the techniques from lecture 6 to look at this initially. So when we've got, if we have 3 variables, excuse me, if we have 3 variables, we can use a bubble plot, but here we've got 10, so we're going to use a radar plot to try and make sense of this. So using exactly the same code as example 4 in lecture 6, we can generate a radar plot of those of that data that looks like that. Let me just run that so you can see it. Okay, so there's a radar plot. You can see there's 25 subplots, so one for each product, and each subplot is a radar plot with 10 spokes. So that's the 10 spokes represent the 10 ratings. So for example, looking at the top left, product A, if I think this horizontal line on the right is the rating 1, so that would be rating 2. So rating 3 for product A is good, but the rest of the ratings are quite low. But you can also see E has a similar profile. Okay, so you would expect those to probably go in a cluster together. Look at something else. D, H, S, and T all seem to have similar profiles. So again, you would expect them to go in a cluster together. And so with this kind of radar plot, we can get a sense of what the clustering might look like. But it's quite hard to spot any actual segmentation just by looking at them like that, especially if we had many more products. So if we had 250 products or 2,500, then there would be many more subplots, or if we had lots and lots more variables, in which case there'd be lots more spokes on each radar plot. So we can do our clustering techniques, and as we saw, it's easy to calculate the optimal number of clusters. We can just use the same code as we used in previous examples in this lecture. So we're using the ratings as the data frame and the ratings.columns as the selected, because we're going to cluster on all the variables. So we're not selecting a set of variables, we're using all the variables, which are all the different ratings. And if you do that, you actually get a nice clear picture where the silhouette method and the elbow method agree with each other, and they have a maximum silhouette score or a maximum or an elbow at K is 4. So there, the blue one is the elbow method. You can see there's a clear elbow there, and there's also a clear maximum of the silhouette score, which has a maximum when K is 4. Okay, so that tells us how many clusters we're going to get. But how do we then, having generated these clusters, how do we visualize them when there are 10 dimensions? We can't use 3D plots. Okay, we can't use. What we could do is use pairs of variables. So we can pick, for example, here is rating 1 versus rating 2. And actually, this is quite an informative plot. This is quite a good one in the sense that what I'm looking for when I'm doing these pairs of variables would be that all the products of one color are in a similar place. So you can see those red products are all in a similar place. They're all obviously high rating for both rating 1 and 2. Then there's this group here, the green ones, which are high rating for 2, but a slightly lower rating for 1. But then these two clusters are a little bit mixed up. There's an outlier value there, so that's not that's helpful, but not incredibly helpful. And if I pick another pair of ratings, this is a particularly bad one. So rating 3 against rating 8. It's impossible to distinguish anything there and therefore make sense of the clustering. What does each cluster represent? So that one is quite helpful. That's not very helpful. And in reality, because we've got 10 variables, if you remember the formula for picking pairs, then there's going to be half times 10 times 9. There's going to be 45 pairs of ratings to look at. So we'd have to generate 45 scatter plots to look at all the different pairs, and that might then prove impossible to analyze visually. So what we're going to need is some what's called dimensionality reduction, and we'll look at that in the next week's lecture. Okay, so what have we seen today? We've looked at the k-means clustering plus techniques for choosing k. As I said, there are other clustering methods. dbScan is a very popular one. Does a slightly different thing, but and also allows for outliers, but it'll give you sort of similar results to k-means usually. We've seen how to choose the value of k using the elbow method or silhouette maximization. Then we've seen a number of visualization techniques. In particular, we saw a new one in action, a 3D scatterplot, which is quite a useful thing to be able to use. In terms of the data exploration, we've seen we can successfully cluster variables with ease. It's just interpreting those clusters as to what each cluster represents can be a bit harder. It's easier when you've got low dimensions. It's easier when you've got small amounts of data, but it gets much harder as soon as the number of dimensions creep up. Okay, and as I said, next week we'll therefore look at a method for dimension reduction. Okay.